When it comes to free and open source software, few tools are as widely used as Notepad++. It's a beloved text editor, and rightfully so, but even great software can have vulnerabilities. Recently, there's been a new CVE published for Notepad++ as Windows installer, and this issue isn't in the app itself, but it's about the way it gets installed. A key issue with it is that older versions of the installer have a uncontrolled search path element bug. In this video, I'll walk you through what the vulnerability is, how it works, and show you a lab demo of the exploit in action. I'll also touch on why some people believe the CVE might be a bit mischaracterized as a privilege escalation when really it's something else. In my uneducated opinion, it seems that there may be some discrepancies in what was directly published and what actually happens during the exploit, but I'll touch on that later and let you make up your own mind. One thing is for certain though, this vulnerability can allow an attacker to gain remote access to your computer when installing Notepad++ under the right conditions. Some quick key points on this vulnerability is that it only affects versions 8.8.1 and below, and the exploit is in the installer itself, so it gets exploited when someone tries to install Notepad++. A big one right here is that you need another exe on the victim machine for the exploit to work. As mentioned in the CVE, the likely attack vector is going to be phishing or social engineering. And lastly, a key categorization for this vulnerability is that it has an uncontrolled search path element. And I'll show you some code in a second that'll explain what that is. In plain English, if an attacker can convince a user to download Notepad++ installer as well as their malicious exe, Windows will run that malicious exe instead of the legitimate one during installation time. We can see what exactly is vulnerable in their code just by going to their GitHub repo and looking at their security advisories. This gives a good amount of information on the vulnerability, but right here we can see red server 32 is called, but they accidentally omitted a path. So since they didn't give a path, Windows will look around the system, and it starts looking in the current directory. So if a bad guy puts a fake red server 32.exe in the same directory as a Windows installer, it'll just run whatever that code is, doesn't matter. And if we look in the impact section, you do see that they say it's a local privilege escalation and unprivileged users can gain NT authority system access. Now that's a bit weird, and I think I'll show that that isn't quite right later. But out of the way, as I mentioned before, an attacker can still potentially get remote access to your system. Alright, let's see this thing in action. As I mentioned, a likely attack vector is going to be phishing, so that's just what I'm going with in the demo to deliver the payload. Now with that, every link in this demo, it's fake, it's only hosted locally in my lab, does not work. But anyways, let's just pretend we're just some user with some sensitive documents on our desktop and we want Notepad++, so we Google it, and then we find this fake phishing link here. But we don't think about it, so we just click it and we download stuff. And oh, we get a zip file. So let me extract that. And then oh, we get the installer for Notepad. So we run that. Click yes to the UAC and go through the install process as normal. And as it's downloading, or as it's installing, we saw a quick PowerShell pop up there. But it went away quickly, and we don't know what it did. But the installation completed fine anyways. And we can run Notepad++. And yep, it works. But what happened on the back end? Well, if we go to our Kali box running in the background, we can see that we establish a netcat connection. So what we get this connection as, let me run a who am I, and we're into the authority system. We can do pwd to see where we're at Windows System 32, and just for fun, let me see if I can access that file on the desktop. And we sure can. There's the contents right there. And with that, we have fully replicated the results of the official POC for the CVE. Okay, so we've seen what this exploit can look like in action, so let's run through how to recreate it. Please note that there are a lot of things this exploit could be used for. I mean, it essentially lets you execute arbitrary programs, and those could be whatever you want. But this is just how I've done it. And I will be using vanilla payloads, which will instantly trigger Windows Defender or anything like that. So since this is just a lab demo and just for educational purposes, especially for anyone dabbling in cybersecurity concepts, I'm turning all the Windows security tools off. I'll also ignore setting up the fake phishing site since it's not needed solely for testing the vulnerability. So I use Kali Linux in a VM. You don't need Kali, you can use Linux, but Kali's just convenient. on that, we'll need a legitimate Notepad++ installer. You can get a vulnerable version just off their website. The versions, again, are listed in the CVE details. And the actual payload will be inside of a fake red server 32.exe, and we'll make that payload with MSFvenom. If you don't know what MSFvenom is, it's popular in CTS, Hackbox, etc. And we'll actually have two different versions of the red server. The first one's it's just going to run the exploit, and the second one will fully replicate the POC, and it does this by chaining the exploit with some more traditional privilege escalation techniques. And that's actually what I used in that first demo I showed. Lastly, on the Kali side, we'll need a PowerShell reverse shell. This is what's going to actually establish communication between Kali and the Windows device. And we will make that just on revshells.com. Again, this is popular with CTFs, pretty common. And lastly, we will just need a Windows 11 device or VM to, try to install Notepad++ on. But with that, we have the option to download Procmon. This is Process Monitor. It just comes in the sysinternals tool suite published by Microsoft, and it just lets us, delve into the back end of Windows and see what's going on, what system calls are being executed and whatnot. You don't need it, but you could use it if you wanted to dive more into what's going on in the back end. For some extra context of why I have this thing set this way, basically have red server 32 acting as a dropper, and it will then reach out, grab this PowerShell script, and make that reverse shell in a new process. And that's because the Notepad++ installation actually waits for red server to exit. And while you could make the reverse shell spawn in the same process as this, it will cause the installation to hang, and the installation won't continue until the reverse shell is closed. But by splitting it up this way, the installation continues as normal, and it can still fully replicate the POC. Okay, let's get to building. So we want somewhere to store all of our files, so I'll just make that mkdir testing, cd into that. Next, we want our IP address, so just ip-bra, copy this down. Next, we need to make the file which will host the reverse shell. I will do touch virus.ps1, and this just makes an empty file. But we need to populate the file. So open up Firefox in Google rev shells. Once that loads, click this first option, revshells.com. Again, it's popular with CTFs. And once you get here, make sure you put in the correct IP address and whatever port you want. I'll leave it as 1337. And then on this filter option down here, just put power and it will narrow down all the shells just to PowerShell. These are all different options you can use, but we will stick with option 1. So copy that. And let's go back to our terminal and then use a text editor of your choice. I will use nano. So just nano virus.ps1 and then copy that reverse shell in there. Just to make sure, I will cat virus.ps1 and we can see that the reverse shell is there. Okay, next step, I just cleared out the terminal and I will copy and paste the first payload command. As I mentioned, there's two different fake red server 32.exes in this demo. That's because one just gets a shell, but the other one can fully replicate the POC and give you NT authority system shell. But again, it has to do that by chaining together some privileged escalation techniques. So that will have to be a different command later. But for now, MSFvenom, the -p is just the payload, so we're Windows 64-bit. And in short, we're running a PowerShell window, which will use invoke web request to reach out to a web server we're hosting on our Kali box. So this will need to be the IP address of your Kali box. And it will grab that virus.ps1 reverse shell off of Kali and then run it. So -f is just the file format, so exe, and output file name redserver32.exe. So I'm going to press enter. And just like that, the first payload is generated. Next step should be a little bit obvious, but we need Notepad++. So let's go back to Firefox and go to Notepad++'s website. Hit download, and we need a vulnerable version, so we are sticking with 8.8.1. Download that installer. And once it downloads, we will put this installer in the same folder or same directory as our other tools. So I'll move it to the desktop real quick, and then where'd it go? All right. So we have the installer, the fake red server 32, and virus.ps1 in the same folder. Okay, last part's on the Kali side. We need to make that netcat listener and then also a web server to transfer our files. So, little fun tip here. Once you're in the terminal, you can actually do Control Shift and then R, and it'll open a new terminal on the right side. And to make our netcat listener do whatever port you put into rev shells, I did 1337, so I'm gonna do sudo nc-nlvp 1337, so the port number. Hit enter on that, put the password. And the next time, we'll just use a little trick that I like to use to transfer files quickly in a lab environment. So we use Python. So sudo python 3 -m for module http.server, and then the port. We'll just leave as port 80. Put the password again. And now we have a web server. And whenever you navigate to this web server, you'll be able to access any of the files that were present in the directory that you ran Python from. Okay, everything's set up on the Kali side, so let's move on over to Windows. There's a few things we need to do here. First, again, this is a lab environment. It's not an AV course or anything like that. So we need to turn AV and all that stuff off. So just look for a Windows security and make sure all that stuff is turned off. Next, for an optional step, I will use this, but you don't need to run the exploit. But I'm going to run procmon. And I'm just going to have that running in the background. Next, go to your browser, and we need to get those files over to Windows. So since we have that Kali web server running with Python, just do HTTP, and then whatever IP address you used, and hit enter. And you can see these are all the files that were in the same directory we ran that Python server from. And we just need the Notepad++ installer and red server 32. And we can head down to our downloads, and they're here. So just install Notepad++. I like to hit show installation details, and we can actually see that red server pop up, that code pop up right there. Okay, hit next and open Notepad++ if you want, but the exploit's executed. We can head back over to Kali, and we see these are the different requests that we made in the GUI. We see red server 32 and Notepad++ installer, but right here we see virus.ps1. So that was the actual MSFvenom payload reaching out in the second stage to download the script. And on this left side, you can see that reverse shell was created. So let me run a who am I. And we can see we are the user that installed Notepad++. So I guess this next part is kind of where it comes down to your interpretation. But let's take a look back at the CVE. In a few parts here, it says it allows unprivileged users to gain system-level privileges through that insecure executable search path. Back here on the score, we can see privileges required L, so low. So it means an unprivileged user. Up here, we can see upon running the installer, the attack executes automatically with system-level privileges. But if you look back on my shell, again, who am I? I'm a local user. This user happens to be an administrator because I have privileges to install applications and write to C program files, but it's not system. Now, of course, you can get system pretty simply with traditional privilege escalation techniques, but still, I think there's a distinction there. Running this exploit doesn't automatically get you system level privileges. Now, of course, you can chain it with privilege escalation techniques to get system privileges, but that's going to require you to already be an admin level user when they try to install Notepad++. We can even go and look back at that procmon that I had running earlier. And what do we see at the top here? We have process name, red server 32.exe, process start, and here's the command line, and it's that vulnerable code that we saw from the security advisory. So I will click on that, go to process, and the user context is the user that was installing it. Again, not system. And yeah, you can see load image. Here's the command line. Also not system. So maybe this just comes down to semantics, but it definitely seems to me like there's some discrepancies on this CVE. But I've showed you this, and it's up for you to decide. With all that other stuff being said, we do know that the official POC did give a system level shell, and my earlier demo at the beginning of the video also gave a system level shell. So I don't know how the POC did it, but I know how you can do it, and that's just chaining a scheduled task privilege escalation technique. So everything else stays the same, just the MSFvenom payload's different. So I can go ahead and put that new command to generate the new payload in here. I'm not going to go line by line, but essentially what it does is it takes the same concept as the previous command where it reaches out to our Kali web server, downloads that reverse shell, and then executes it. But instead of doing it directly, it creates a scheduled task and then executes that scheduled task with system level privileges. And then it runs it immediately, of course. But the only reason we are able to schedule this task and then have that task run with system level privileges is because the user that installs Notepad++ was an admin or a local administrator on the computer. So again, it does seem kind of contradictory to what the CVE says, where a unprivileged user can get system level privileges. But either way, here's the command. Now I'm going to hit enter. And a reminder, I'm in the same directory as before, and I will start that netcat listener. And make sure that your Python web server is running again. And then go back to the Windows side. And should mention this, you're going to need to reset Windows if you want to try this again. You need to uninstall Notepad++ and make sure that virus protection didn't turn back on. But same as before, we're going to go to our Kali web server through the browser, download the installer and that fake red server 32, go to downloads and run the install. Yep, same thing as before. PowerShell popped up once we hit that red server 32 part. And installation is complete. Notepad++ works. And let's head back to Kali. Alright, same thing we saw last time. Virus.ps1 was gotten. And we have a shell. So let me run who am I? Anti-authority system. And print working directory. We're in Windows System 32. Well, that's pretty much all I got. Feel free to let me know in the comments if you think that me saying there are discrepancies is completely off base and I'm wrong. Or maybe you think I'm right. Maybe you agree. Either way, one thing was for certain. There was definitely an exploit here. Definitely a vulnerability. And this was a nice little fun one to try out and poke around with. It's pretty easy to replicate the POC. But either way, at the end of the day, hope you learned something.